Welcome to Training 5, FHIR in Practice for Public Health, Bulk Data Access. In this session, we explore how FHIR supports large-scale, population-level data exchange through a mechanism known as bulk FHIR or flat FHIR. By the end of this session, participants will be able to explain why traditional FHIR APIs are insufficient for large-scale data needs. Describe how FHIR Bulk Data Access supports population-level data exchange. Understand the core workflow for bulk FHIR, including asynchronous export and ND-JSON formatting. Identify key public health use cases for bulk FHIR. Outline the security, authentication, and onboarding process for bulk FHIR clients. And lastly, explore a real-world example from the Rhode Island Child and Adult Immunization Registry. While traditional FHIR APIs work well for querying individual records in real time, they become inefficient when dealing with hundreds of thousands, or even millions, of records needed for population health monitoring, surveillance, and registry operations. Public health agencies increasingly require scalable solutions to manage data at this scale. Bulk FHIR is a specification developed by HL7 in partnership with the SMART Project and Boston Children's Hospital. It enables the export of large datasets from a FHIR server in a single job. Rather than sending many small, synchronous queries, clients initiate a single export operation and receive all the requested data in one or more downloadable files. This process is asynchronous, meaning the server acknowledges the request, processes the data in the background, and later notifies the client when the files are ready for download. The exported data is delivered in a format called ND-JSON, which stands for New Line Delimited JSON. This format allows each line of the file to represent a separate FHIR resource, making the files easy to process in parallel or load into modern data platforms. The bulk FHIR IG published by HL7 provides background and additional information on implementing population-level data export. Bulk FHIR supports several types of export operations. Patient-level export retrieves data for all patients on the server. This option may be helpful when evaluating the long-term effects of a particular condition. In this scenario, you may want to export all data to analyze outcomes and trends in post-acute care. Group-level export retrieves data for patients defined within a specific FHIR group resource. This is particularly useful in public health for cohort tracking. For example, monitoring a group of patients across several counties. A group resource is created referencing these patients, and an export is initiated to retrieve detailed case, lab, and treatment data for that cohort. Finally, system-level export retrieves all data from a FHIR server. This may be helpful when migrating an entire system or registry to new infrastructure. Because bulk FHIR uses standardized resource types and vocabularies, it facilitates data reuse across programs and jurisdictions, reducing duplication and integration costs. The bulk FHIR export process follows a clear, repeatable workflow. Before any data is exchanged, public health clients must register with the data provider. This is a one-time process that includes submitting a public key and organizational metadata. In return, the FHIR server issues a client ID and endpoint information. Bulk FHIR uses smart backend services for secure, system-to-system authentication. The client generates a short-lived JSON Web Token, or JWT, signed with its private key and exchanges it for an access token from the authorization server. Next, the client sends an export request, being sure to include the provided token. The server acknowledges the request and returns a content location URL to check on the job status. The client periodically polls the URL to check if the export job is complete. When ready, the server responds with download URLs for each ND-JSON file. The client downloads the files, which may include resources like patient, immunization, observation, and encounter. The files also include metadata such as record counts and timestamps for audit tracking. This entire process is automated and can be scheduled to run on a regular basis, such as daily, weekly, or monthly, depending on public health reporting requirements. The bulk FHIR specification includes several query parameters to optimize the export. The since parameter limits the export to data created or updated after a specific date, enabling incremental updates rather than full exports. The type parameter restricts the export to specific resource types, such as only immunization or patient. The elements parameter allows selection of specific fields within a resource, for example only export patient name and patient birth date. These parameters make exports more manageable, reduce processing time, and help tailor the data to the public health agency's exact needs. However, not all servers support all filters. Agencies must review the FHIR capability statement to determine which options are available. A compelling real-world example of bulk FHIR in action can be seen in the Rhode Island Child and Adult Immunization Registry, also known as FHIR. To support high-volume immunization data exchange with various trading partners, Rhode Island adopted a bulk FHIR architecture that enables scalable, efficient retrieval and sharing of immunization records. At the core of this implementation is a FHIR server, which Rhode Island uses as a facade. This means the server does not store FHIR data natively. Instead, it maps underlying registry data into FHIR-compliant formats dynamically, enabling compatibility with modern standards without the need to rebuild backend systems. New partners are on board through a one-time registration process in which they submit a public key and receive a client identifier. With credentials in place, the partner initiates a bulk FHIR export operation targeted at a FHIR group resource that represents their patient population. This operation supports exporting immunization and related records for all individuals in that group. Rhode Island also supports several useful FHIR operations that enhance flexibility. Partners can define or update cohorts using the member add and member remove operations. Patient identity resolution is handled through the patient match operation, which helps prevent duplication and ensures that export jobs return the correct data for matched individuals. The data returned is formatted as ND-JSON, new line delimited JSON files, organized by resource type, such as immunization, patient, or observation. Once ND-JSON files are received from a bulk FHIR export, public health analysts can use a variety of widely available tools to extract meaningful insights. Python, combined with the Pandas library, is a particularly useful toolset for loading ND-JSON files into tabular data frames. Bulk FHIR is designed with strong security and compliance features. All data exchanged through the bulk FHIR API is encrypted in transit using Transport Layer Security TLS, ensuring the confidentiality of the payload. Authentication and authorization are managed through OAuth 2 protocols and JSON Web Tokens, which help validate that only approved, credentialed systems can access sensitive health information. These access tokens are short-lived and scoped to specific permissions, minimizing the risk of unauthorized reuse. Systems track timestamps, request metadata, and download logs to support monitoring and compliance. It is important to ensure that data use agreements, privacy impact assessments, and appropriate regulatory safeguards are in place, especially when working across jurisdictions, or when cloud platforms and third-party services are involved. Despite its many benefits, bulk FHIR presents several implementation challenges. First, exporting large volumes of data requires robust backend infrastructure. FHIR servers must be able to queue, process, and deliver large asynchronous jobs while balancing performance and availability. This can be a limitation for smaller systems or vendors not yet optimized for bulk operations. On the client side, public health agencies need technical tools and expertise to work with ND-JSON data. This includes the ability to parse, validate, and transform bulk exports into formats compatible with internal systems, especially those still based on legacy HL7v2 or flat file structures. Another challenge involves data mapping. Even when using standardized FHIR resources, each implementation may have slight differences in extensions, terminology bindings, or field usage. Data often must be normalized to fit into existing surveillance or registry workflows. Finally, not all FHIR servers support the full range of bulk FHIR operations or filtering capabilities. Reviewing the server's capability statement and conducting conformance testing are critical steps during planning and onboarding. Despite these challenges, adoption of bulk FHIR is increasing, and more vendors are aligning their systems with the specification. Community collaboration, pilot testing, and engagement with FHIR accelerators like Helios can help address implementation gaps and promote consistency across jurisdictions. In summary, bulk FHIR represents a powerful, scalable method for public health agencies to retrieve population-level health data in a standardized and secure format. Its asynchronous design, use of modern security protocols, and support for flexible filters make it especially well-suited for large-scale analytics, registry management, and surveillance. The Rhode Island immunization case study illustrates how bulk FHIR can streamline onboarding, reduce integration costs, and enable efficient, high-volume data exchange. Combined with widely available analytic tools like Python and visualization platforms, bulk FHIR empowers public health programs to transform raw data into actionable insight. As more systems adopt FHIR and public health infrastructure continues to modernize, bulk FHIR will play a vital role in supporting timely decisions, rapid responses, and improved outcomes for communities across the country. Thank you for attending this session.